Hello, we've got a statistics video for you today where we're taking a look at standard deviation, showing you how to calculate it as well as hopefully explaining what it is. And in fact, that'll be a great starting point. What is standard deviation? Yet, before I'm actually able to properly answer that question, I should acknowledge that there's actually more than one type of standard deviation. There's what we call population standard deviation, and then there's separately something called sample standard deviation, which is usually represented by the letter S. Interestingly, for Maths A-level, we only bother looking at population standard deviation. Although sample standard deviation is something you might come across in some other subjects, it's not something we look at in maths unless you're somebody who goes on to take further maths and ends up doing a lot of the statistics content in that qualification. So therefore, for the purposes of the rest of this video, whenever you hear me talking about standard deviation, I am referring to specifically population standard deviation. Okay, now with that said, what is standard deviation? Well, it is effectively what we call a measure of spread, which is a posh way of saying it's something that measures how spread out the data values in a data set are. However, that's a bit weird because we already have a way of doing that. Hopefully you've already come across range, which is another measure of spread. However, the problem with range is it's a bit too simplistic. Range only takes into account the smallest value in your dataset and the largest value in your dataset, which also doubles up as an advantage because it's very easy to calculate, but it means it's not giving you a good overview of what the entire dataset is doing. Whereas standard deviation takes into account all the values of your dataset to then give you an overview of how spread out all the bits of data are. I can try to give you a bit of a visualization of this. For instance, we could have a dataset which has the four numbers 2, 4, 9 and 11 in it, only those four numbers. And then we could have a second dataset which has got the numbers 2, 9, 10 and 11 in it. I've then also shown you a number line with these numbers marked on just to give you a visual representation of where these numbers are placed. The interesting thing is if you work out the range of that first data set, it's just going to be 11 take away 2, which is 9. In other words, it's going to completely ignore the 4 and the 9 in the data set. And if you calculate the range of the second data set, well, it's also going to be 9 because it's going to be 11 take away 2 again. It again completely ignores the numbers in the middle, in other words, the 9 and the 10 in this case. The problem is this doesn't give a true reflection of what's really going on with these datasets. With the first dataset, we can see the data values are spread out more evenly across the interval they're appearing on, whereas with the second dataset, more of the data values are grouped together in close proximity. We can see the 9, 10, 11 close to each other, and then there's just that one value of 2 that's then miles away from the rest of them. This is the advantage of standard deviation though. It will reflect more of these differences in the calculation it does, because the standard deviation of that first dataset is 3.64 and the standard deviation of that second dataset would be 3.53, and you can therefore see the bigger number of standard deviation being for that first dataset where the numbers are more spread out overall. However, you might be disappointed to see that actually the values for standard deviation in these two cases are quite similar to each other really. The reason for that though is just because we're dealing with such small data sets. If you had these data sets including more numbers and they were more closely grouped to the numbers you can already see for the first data set, whereas then for the second data set you had more numbers but they were all still just near the 9, 10, 11 only, then in which case actually the standard deviation for that second dataset would drop significantly from what it currently is, because that 2 would then be appearing as more of an anomaly compared to the rest of the data values. Okay, so that's what standard deviation is trying to do, but how do we actually calculate it? How does it work? Well, to calculate standard deviation, the first thing that goes on is it uses the mean as a reference point. And what we can then do is we can then calculate the distance that every data point is from that mean of the data set. What you then might be tempted to guess is that we would then just take the mean average of those distances from the mean, because then that would show you how much on average the data is spread out from that vaguely central point of the mean. But actually that isn't the case, because that's something different, something that we would call mean absolute deviation, But mean absolute deviation is not what we're trying to find right now, and it's also not something you actually need to know for A-level study. So therefore, we're going to ignore that, and we're going to continue on with standard deviation. Because instead, what standard deviation does with these distances is it then squares them. What this means is that the standard deviation puts a bigger emphasis on values that are further away from the mean, because bigger numbers get more affected when you square them, and so therefore this standard deviation measure is particularly useful for being able to also see if a dataset has a lot of outliers in it. Once we've squared each of those distances, we're then going to find the mean of those values. And then once we've done that, to finish it off, we're going to square root that result, and that will calculate the mean for you. So, showing that put into action, if we have a very small data set of 1, 2, 3, and 6, we can start off by calculating the mean, which of course would be adding up all the bits of data in the data set, and then dividing by the number of numbers, which in this case is 4 numbers. If you work that out, you will get 3. Cool. What we can then do is we can work out how far away each of these numbers are from that mean by doing these data values, take away the mean. And therefore, working that out for each of those cases, we'd get 6 take away 3, which is 3, 3 take away 3, which is 0, 2 take away 3, which is -1, and 1 take away 3, which is -2. You might be a little freaked out by the fact I've done the dataset value take away the mean for those lower values, because it has meant we've ended up with a negative number, which would seem to be a bit weird if we're finding a distance. But it's worth pointing out the next step of finding standard deviation completely means that we don't worry about the fact we've got negative numbers here, because now we're going to square each of these values. So 3 squared is going to be 9. We've got 0 squared, which is of course 0. -1 squared, which is 1, and -2 squared, which is 4. So the fact we're squaring each value means that the fact that some of them are negative doesn't matter, because all numbers squared will end up being a non-negative value. We're then going to find the mean of these values. So the mean of these values would be 9 plus 0 plus 1 plus 4, all divided by the number of numbers, which would therefore be 4 in this case. And then, once we work that out, funnily enough, that will come to 3.5. And then the final stage is to realize that the standard deviation would be that value square rooted. And that would come to, in this case, 1.87 to 3 significant figures. So that's the process that could be used for finding the standard deviation if you were doing it manually. However, I must tell you that in reality you should never bother actually calculating the standard deviation manually like this for A-level study, because it takes a long time and you're not going to be given the marks for the amount of time it's going to take you to do all this. Instead, if you're ever asked to just find the standard deviation of a data set manually, instead what you'll be expected to do is to just use the statistics mode that appears on most scientific and graphical calculators to just have an instant way, once you've typed all the numbers in, of finding what the standard deviation is. So do bear that in mind. You're never actually going to be carrying out the process we just did there on the screen. However, with that said, you are sometimes required to calculate standard deviation using a formula. So what is that formula? Well, first of all, I should introduce some notation, and that is that we represent standard deviation by using the lowercase Greek letter of sigma. That is that letter that looks a bit like an O with a weird tail on the top. Anyway, standard deviation can be calculated using this formula. Or alternatively, it could be calculated using this formula. Both these formulas are doing the same thing, they just look different. And it's also worth mentioning that they are both in the formula booklet. However, ironically, that second formula is presented in a bit of a weird way in the example that I teach for its formula booklet, because what it does is it instead tells you what SXX is as a formula, and then tells you that standard deviation is the square root of SXX divided by n. Of course, you'll realize very quickly if you combine those two things there, that is just saying the same thing as the thing up above there. Cool. But the problem is, some of you are probably looking at these formulas and wondering what on earth is going on, because there's some weird notation in there that you might not have come across before. So to explain that, the first thing we'll start off is with that weird capital E looking thing, except it's not a capital E at all, it's actually the capital Greek letter of sigma, which is confusing because we use the lowercase version of sigma to represent standard deviation, but the capital version of sigma represents in maths the word sum. So therefore, if you see sigma x, that means the sum of all the x values. And if you see sigma x squared, that means the sum of all the x values after they've been squared. It is worth mentioning BIDMAS applies here, BODMAS, PEMDAS, the order of operations basically. So that does mean that we have to square the values individually first, and then we are adding them together afterwards. So that's something bearing in mind because some students make the mistake of thinking that they could just add the numbers together first, then square afterwards, but that would be represented in a different way with brackets to make it clear what order those operations are happening in. Okay, and then you've also seen the letter n in those formulas, and n just means the number of bits of data you have in your data set, the number of numbers, if you will. And then lastly, there was that x with the straight line on top of it. That notation is called x bar, and it means the mean average of x. So whenever you see that, it's of course something you're already familiar with, but just because it's got this weird notation, some students freak out, but you don't need to. And because we already know how to calculate mean, weirdly we can then choose to write it using some of this posh notation. As mean is usually calculated by adding up all the numbers and dividing by the number of numbers, that could be written as sigma x divided by n, based on what those two individual bits of notation mean. Okay, now we know what the notation means, we can actually have a go at starting to use these formulas. So let's look at an example. We've got a set of 11 numbers, except we haven't actually been told what those numbers are, and that's how we know we need to use the formula rather than just typing all the numbers into the calculator and using a statistics mode to just instantly calculate what the standard deviation is. So because we don't know the individual numbers, instead we're having to use the formula because we've been given parts of the formula. Except you probably want to know what those formulas are. So a reminder, they are those two formulas up in the top right hand corner of the screen. So with that said, the formula we're going to want to use for this first example is the formula that's on the left, because we've got individually sigma x squared and we've also got sigma x. So therefore all we've got to do to begin with is work out the mean, and the mean is going to be the sigma x divided by n, so therefore that is 44 divided by, well, 11, because we've got 11 numbers in our data set, we're told. So that comes to 4, so that's the value of our mean, and now we've got that value, we can now work out the standard deviation. Standard deviation will equal the square root of sigma x squared, which is 246, divided by n, which for our example is 11, and then we're going to subtract the mean all squared, so mean squared would be 4 squared, and then we're square rooting all of that. So if you type that into a calculator, you will get 2.52. Technically 2.522624, etc., etc., but therefore it does just round to 2.52 to 3 significant figures. Okay, that's our first example, but let's take a look at a second example. And our second example, with this time got only 6 numbers, and instead we've been given sigma of x take away x bar all squared, which looks really scary, except it's really not a problem, because it just means we're going to be using the second of the two formulas, the one that's on the right, to calculate standard deviation instead. So actually it's going to be quicker this time, because all we've got to do to calculate the standard deviation is do sigma of x take away x bar all squared, which was 1254, divided by n, which this time is the number 6, because we've been told there were 6 numbers in the data set, and then we've got to square root all of that. If we type that into a calculator, you will get a final answer of 14.5 to 3 significant figures. Okay, so that's me showing you how you can calculate standard deviation if you are using the formulas. As I said though, if you're just given the dataset in bulk, you would not try and calculate it manually, you would just use your calculator to do it for you using the relevant mode, just because this reflects what you do in real life. Ultimately, computers are very easily able to calculate standard deviation. A lot of computer spreadsheet packages do often include a ready-made standard deviation calculator as part of them, including Microsoft Excel. So there you go. One last thing I want to cover though before we end the video, which is to explain what variance is. We're not really going to do anything with it at the moment, but just so you're aware, variance is just the value of standard deviation then squared. Or in other words, another way of viewing it is it's just standard deviation without the square root sign involved. So we're not going to do any calculations with that yet, but in case you see that term crop up as part of any maths, now you know what it is. It's just one little change away from what we do with standard deviation. Okay, hopefully you found today's video useful. I'll see you in a future video. Goodbye.